Hello, dear students. Here is your teacher Google profile, Vipin Sharma Physics, and I am going to tell you inertia from a very simple example, which I'm trying to decode it from the day-to-day life. First of all, generally I ask who has given the concept of inertia. It is basically given by Sir Galileo, not by Isaac Newton. In day-to-day life, we can decode inertia from numerous practical example. This is one practical example. He is trying to move it, but finding it difficult. But there's rest. Now it is in the motion, so it is continuously moving. Now, another beautiful example. See the truck, and it's coming towards me. Let me get aside. The truck is coming, and see, this is untied. Tied brake strikes at the back. Strikes at the back. When it strikes at the back, because the upper part, this upper part continues to be in motion, the lower part suddenly comes to at rest. When the lower part suddenly comes to at rest, similarly, these are the coins of the theorem, right? Now we are applying it with the striker. The lower part jerk, quick. So that is just taken away, and the other remains in contact because of inertia of rest. There are so many other examples. I'm trying to explain you through this simple concepts. This lower coin. Now the satellite continues to be in motion. It is orbiting around blue planet Earth. See, the satellite is revolving because there is no external force which makes it to stop once it is in motion, so it continues to be inertia of motion. So many practical examples you find in day-to-day life. And one more practical example I would like to tell you. Once again, I explain you about the carom. See, with the striker we hit at the bottom suddenly comes into motion, and the upper part remains at rest. So all the coins in the upper region, they remain intact, means they are not getting displaced and dispersed. Only the lower part is just moving because of inertia of rest. A body remains at rest, inability to change its state of rest. The lower part. Now the satellite. See, this satellite is revolving around Earth. When satellite is revolving around Earth, and it continues to revolve around the Earth because there is no external agency to stop it. So this satellite is moving around the Earth continuously. You can't stop it. So that is inertia of motion. Similarly, I'm going to explain one more example in day-to-day life, which is very commonly you see when you travel, and this man is standing in a bus. The bus is at rest. Now when the bus starts, he falls backward. Why so? Because his lower part suddenly comes into motion, upper part continues to be in the rest position. So that is inertia. Interesting. Now scene, I will change it once again, and I request the operator to just make it the forward directions. Now the bus is moving. He is going to get fall forward because the driver suddenly applies the brake. His lower part is continuously suddenly comes into state of rest in the lower part, that is being flickering, and the upper part is in motion, so he falls forward. So interesting is inertia. See, inertia is proportional to what? Inertia is not same for everything. See, this is having lesser inertia because it is empty, and this has more inertia. So inertia is proportional to mass. Inertia is proportional to mass. Now look here, as you have increased the mass, it's difficult for us to change the state. So more is the mass, more is the inertia. You can kick a football, but you can't kick a stone because it has more mass, right? Same way, I'm going to show you something very interesting. Kindly operator, show the coin and that metal coin and all. right? So he's trying. Yes. Now see, this is a nickel coin train. This is car. This is plastic coin. This is nickel coin. Which has more inertia? The train, because more mass. Car, less than train but more inertia. Then the steel coin, nickel coin, and the plastic coin has got a very little inertia. So this is how inertia is proportional to mass. So inability of a body to change its state of rest or motion of itself is called inertia. So this man, see the drivers, he is tying a belt. Why it is so important, even you get to know, when he will suddenly apply the brake, he falls forward. Had there been no belt, he might have banged into the steering. His chest may have collapsed. So therefore, wear steel belt. Physics tells you. So all nature is physics, and you decode so many physics from day-to-day life. So dear students, how you like this kind of explanations, which I'm trying to decode it with the help of some day-to-day life examples. Now hope you will love it. Thank you. See, inertia. So we are belt. Thank you.